Before we start, first of all, I would like to get to know you. I want to know who is present in this. So I'm asking you, all those who are directly involved in maintenance in production, like engineers, managers in maintenance, who directly work with the maintenance in production, are here with us. Please raise your hands. Thank you. Please raise your hand, all those who are directly involved in production of maintenance, like line managers, shift managers, maybe operators. And please raise your hands, all those who work as CMMS designers, developers, or IT experts. Thank you. So I guess you are familiar with this slide. Maintenance and production. Should be communication as push-pull. But who is pushing and who is pulling? Raise your hand if you agree with this slide, because it's quite interesting. Is someone who disagree with this? Okay, thank you. Allow me to introduce myself. I'm Igor Dimitrievski, Manager of Service and Maintenance in Pharmacy Production. I come from Alkaloid, Skopje, Macedonia. Welcome to this discussion where I will try to show you the reasons for the design and the design of the CMMS system, in which, in addition to functionality, must also satisfy GMP regulations. Let's go a little bit in the history. I have been in Alkaloid since 2008. At that time, the communication between production departments and service was via intercom devices placed in each production room, connected to two devices, one in the electrical and one in the mechanical workshop. Reporting of downtimes was done by calling these two devices, often without many details about the problem and often without feedback if someone has received the message. The daily records for the intervention were entered in the notebook with a very difficult traceability of the events. The picture shows the intercom devices and the notebook, which were the only way to register and archive the events. You must agree with me that is the primary reason that causes the situation shown on the previous slide. As the main reason for starting with the design, development, and implementation of the CMMS solution, I can list the achievement of better communication with the production department, a better overview of the status of the production equipment, increasing the efficiency of the processes, and complete control of the processes in service and maintenance. We've decided to develop our own solution because we saw a chance that in addition to these benefits, we could optimize the processes. So as I have published in one of my previous posts, that digitalization is important, but optimizing processes is what truly drives progress. So now we have a solution that's a seriously useful tool that, in addition to fulfilling the set basic goals, successfully contributes to increasing the efficiency of both service processes and production capacities. As I emphasized, Alkamos is just a tool that we use as a means of managing and controlling processes. Foundation on a successful and high-quality maintenance sector is the production in the production premises. The professional skills and professional approach of all employees from different professional profiles must be present and be on a high level. Alkamos is a web-based application supported by an Android application installed on the user's personal Android devices. Users receive the work orders while they are in motion and down the production premises. Notifications for new work orders are received only by users who are currently free and assigned to a current shift and belongs to the area for which the order is created. In the beginning, we started with the simple work orders related to production equipment. And in order to meet the GMP criteria, we reached the point of linking each work order to the product and batch number on each production equipment. We have special orders that refers to equipment that is not related to the product, like laboratory equipment, utilities, etc. Dedicated orders for cleaning, change of product batch number, size changeover, order for general intervention that are not related to equipment, and conditional order that follow a certain flow of events. This will be the focus when we talk about the formal changeover model. It is specific that several interventions can be recorded in each work order. That is, as long as the server technician notices an additional defect different from the one reported in the work order, there is no need to create a new order, but the new intervention is added in the same work order. So we have full traceability for the intervention in one work order. The work orders for the preventive maintenance are not related to the product and the production batch, but they are guided by the created plan for preventive maintenance of the individual equipment, in which activities for preventive maintenance are defined. Users and supervisors are assigned for each activity, and the time schedule for the performance of the activity with two tolerant periods are defined. The designated users for the activity receive a notification for the planned activity, and if it is not carried out within the established tolerance period, notification also reaches the supervisor. The work orders are created through a direct link from the given notification, and the special reports are created for the preventive maintenance of equipment. In addition to the time-based order for the planned activities, if it is noticed that a problem directly related to the planned activity has appeared before the planned time comes, the systems allows the creation of incident work orders for preventive maintenance. The next challenge we faced was the management of the spare parts. We have entered, Sorry about this. The next challenge we faced was the management of spare parts. We have entered the warehouses into the system and assigned location for each part separately with information on the minimum quantity. Then we've entered all parts that we have on stock. When confirming the intervention in the order, the user records the picked up and used parts from the warehouse. With this, we have information on which parts are used in the order, faster finding of the parts in the warehouse, and updating the current state of the stock. When the stock of a part reaches the minimum defined number, the system sends a notification for order planning. Additionally, we create special reports for used and important parts in the warehouses. By adding external controller to each of the lines, we managed to provide signals that in combination with the data from Alkaloid are used to calculate the OEE of each of the lines. We created a special application which communicates and exchanges data with the controller on the one hand and with Alkaloid on the other, and based on that data we get a graphic display and at the same time detailed reports on the production process. All reports are generated in the Alkaloid system. With this, we get a complete integrated solution that, in addition to managing service intervention, also has control over the efficiency of production lines. The last model we developed is the management of the changeover and format paths of production lines. First, we entered all parts, size and formats in the database, linked them to the location in the warehouses, and implemented the 5S standard. Next, we related each format part to the type of packaging, material, and production line. Then, we assigned size and format parts to each product. For one size parts, we connect more format compatible parts, so we digitalize the list with size and format parts per product. When opening disassembly order, the next product is defined, and the disassembly list is created according with that, according to which the parts that are not needed from the line should be removed, the parts that can be used for the next product should be left on the machine. The removed parts are returned to the appropriate position in the warehouse, and after closing this order, order for assembly prepare is opened. This work order can be opened only if the system recognizes a previously closed order for disassembly. With this, we ensure the flow of the process and confirm that the removed parts are in their position in the warehouse and available for use with another product. In the assembly preparation order, the defined product in the disassembly order is confirmed, with the possibility to change it even after opening the order. An assembly list is created with format parts which exactly mark position in the warehouses. The parts are taken over, placed by the machine, and confirmed in the list as taken over. After closing this order, the system allows the creation of a work order for assembly of parts, and the parts according to the list are placed on the appropriate places on the line. This is how the list for disassembly and for the assembly preparation of the format parts look like for each product and for each production line separately. In the disassembly list, the parts marked in the field with a red frame must be removed from the line. Those with a green frame can remain on the line and be used in the next production, and those in a yellow frame for some reason are removed from the line before the disassembly order is created. In assembly preparation list, the parts lined with the red frames should be taken from the warehouse, those with the green frame are already left on the production line, and those with the yellow frame are not available, i.e. they are used for another product on another line. Until all parts are prepared, the order for preparation cannot be closed, and the next order for assembly with the changing of product batch cannot be created. After closing the order for assembly preparation, an order for assembly is opened in which the new product batch is entered and the type of assembly is selected. We are going back to the master data. For all this to work, the system needs master data. related to each other, starting from the creation of localities at the level of the organization, departments in the localities, areas of interest such as, for example, electrical or mechanical intervention, and organizational unit to which the users are assigned. With the corporate infrastructure, resources are connected, regardless of whether they are production or not directly connected to the production process. Production lines and the machines are assigned to location and to the department, and for each of them it is possible to choose whether to be connected to the module for changing format or the OEE module. For each equipment, relevant documentation can be added and can be assigned a responsible user who receives special notifications. Machines as assemblies are fit in the line can be added to the production lines, as well as instruments that are subject to calibration. Each line can be easily integrated with the related production equipment in a higher system, i.e. MES. Additionally, in the system, we have created a special table for the product portfolio. We have entered each product, and for each we have enabled the entry of physical parameters, both for the semi-product, like tablets, capsules, semi-solid forms, and for the final product, forms of primary and secondary packaging. With this, all forms of products and all types of blisters, strips, tubes, bottles, and boxes used in production are provided with detailed physical specification. Every product has the possibility to assign size and format parts, and every product is assigned to the production location and equipment. This is the presentation that is the idea of one product, where its appearance, shape, and dimensions are shown within the framework of the semi-product tablets and the final product blister. So we have this for all types of the products and all different product names in our system. Users can be created in a local table, but can also be integrated with the corporate Active Directory server. For each user, membership in location department and organizational unit is defined, and areas are assigned to him. The user can create work orders only in the localities and departments to which he belongs, and he can get orders for the areas he belongs to. The system is flexible and allows the creation of privileges and user group at the administrator level. In addition, every user who works in a shift selects the current shift and receives orders only if he is in the current shift. About integration with the other system, we have full integration with corporate Active Directory server, so the user can log in with their corporate username and password. But all privileges and functionality are guided through the Alkaloid system. MES integration is on the production line level, so we add option to merge lines from Alkaloid database with the lines from MES database. From MES, we are receiving batch number, mass work order, planned quantity, and batch start time. Alkaloid sent to MES maintenance work order number, response time, efficient work order time, and intervention description. Always, when new work orders is created in Alkaloid, system check in MES, is there a new production batch number on the selected line? If there is, in Alkaloid, user must create work order either for product batch number change, or if it is the same product, or work order for size changeover if it is a new product. In this work order, batch number is automatically taken over from the MES, and with this we can connect work orders. We can connect work orders in the MES and maintenance work order in the Alkaloid. Regarding, beside this, we prevent any mistake that could happen during typing the batch number. Regarding regulatory demands, we've designed the system to be fully compliant with the 21 CFR Part 11. We have audit trail. We have audit trail for every activity and validate reports for different demands. Next step is to implement a sort of artificial intelligence that will help us through searching the databases, and will help to search the events that become earlier in the equipment. So thank you. So please, if you have any questions, I will be glad to answer you.
Thank you very much.
Thank you.
Okay, we definitely have time for questions. Who has a question for Igor?
Thank you for that interesting information sharing with us. You talked a lot about an Alkaloid system. Is that something that you built yourself, or is it on the market?
Alkaloid, thank you for asking. It's a very good question, and I expect this question. Yes, Alkaloid is the system that we've developed in Alkaloid. It's developed by engineers in the maintenance. It's designed by the engineers, and it's developed by external programmer. but the full design is by the engineers in Alkaloid in the maintenance department.
Very impressive. Wow.
Thank you.
Who's next? Okay, from the questions table.
Hey, Dimitri, thank you for the presentation. So what made you develop it, your legacy system rather than buying one existing?
Because, as I said in one of the slides, we find a way to optimize our processes. We are maintaining a very different type of equipment. We have 4 departments in production. We use this system in the laboratory. We use the system in the R&D equipment. So there is a lot of equipment to maintain, and we cannot find the appropriate solution that can find with our needs. So that's why we decide to develop something our own, and it's much easier to upgrading our needs. We build this system step by step. We started, as I said, from the simple work orders, and we finished with the size changeover model. And we are continuing. It's very easy for us, to run the upgrades for our needs when we know the core and we know the basic of the software. That's why we've decided to build it our own system.
Okay, so the digital transformation you just underwent led you to develop a software that supports your processes. Is the inverse happening now? Is the software changing your processes now? Now that you have a software?
Absolutely yes.
Yeah.
Absolutely yes. Absolutely, we are more efficient.
Okay, thank you.
Anyone else from the questions table right here? No? Okay, who's next? I was going to do the going once, going twice, but here we go.
You talked a lot about work orders. What happens if a work order is not completed? How is it seen?
What do you mean by not completed?
One of the parts is not changed, or one of the technicians didn't complete it yet. It stops the whole process, or how do you recognize it in the system?
You mean if it is not effective, the activities in the work order?
Or not done, or not picked up?
We have teams with team leaders, engineer who guide 6 of them or 7 of them of technicians, and this engineer is following the processes of the work orders. The system of work orders is 1 by 1. We have big TV screens on our workshops with lines red, green, and always we are in communication. We are always in line to see if the work orders are opened. So first seen, first taken. That's how we work. There is no randomly selection of work orders. First seen, first taken. So when we see the technician that is take over the work order, automatically his team leader need to follow the intervention in this order. Yes, it happens. Someone somehow just to fix something else, to put the tape on it, and I fix it, he closed the work order. But we have, in that case, a reaction from the production. We have new work order from the same activity. So we follow these steps. If we have the same work order for the same activity and the previous one is closed, like I've done something, I don't know what, but it's working. If we have repeatedly of the same work order with the same description, we have reaction from the team leader. And as I said, this is just a tool. We must work with the people. We must have well-trained people who work on the machines, who work with their hands. This is the core of the good maintenance. As I said, the maintenance and production is push-pull, but the maintenance and the CMMS is also push-pull. But in this case, the maintenance is this one who need to pull. CMMS need just to push, to help a little bit, to have some traceability on, or as I said now, to find with some sort of artificial intelligence to help us to this, like some improved the search engine. But the people are most important in these cases. That's why we've decided to have teams with a team leader who is following the team of 6 or 7 persons. because we are quite a good team. We have in maintenance approximately 70 people who work in production pharmacy, who work in 4 departments, in 3 shifts. So that's why we need to do this separation. So I will repeat again, the people are most important. The software is just helping us. And this is one of the reasons, that's why we didn't buy the solution, that's why we develop our own solution. And I must be honest, it's much cheaper at the end.
Okay, thank you.
Thank you.